Hey children, and welcome to this ICSE session on cylinder, cone and sphere. Basically in this particular chapter we are going to deal with cylinder, volume, surface area, cone same volume, surface area, and also surface area and volume of sphere and also hemisphere. So we can also have questions based on combination of solids. So let us see the variety of questions that are generally asked in the board examinations. But before that, let us see how many questions are actually there in the exam from 2018 to 2024. So if you see, this chapter stands very important in terms of a 4-mark question. Every year, at least one question of 4 marks is definitely asked. Even you can expect a 3-marker, because if you see back to back here in 2018, 19, 20, one question each was asked. Even in 2020, 2 questions were asked. But if you see in 2024, 2 questions straight away from this particular chapter were there in the board examination. So long question are going to be very important from this particular chapter, especially a 4-marker. Here if you see, again if you want, if you can take a screenshot of this 4-mark question, as I said, is very important from this particular chapter. So let's dive in the question straight away. The first question says, the circumference of the base of a cylindrical vessel. Circumference of the base of a cylindrical vessel is 132 centimeter and its height is 25 centimeter. First, find the radius of the cylinder. Second, find the volume of the cylinder. Okay, so circumference of the base of a cylindrical vessel. So we have a cylindrical vessel. The circumference of the base. Circumference of the base. So can I say here, the base is a circle. Base is a circle, correct? Circumference of the base is given. So can I say circumference of the base is nothing but 2 pi r. That is already given. How much? It is 132. I'm just writing down whatever given information is there. We'll continue with the question. And its height is 25 centimeter. So height is 25 centimeter, correct? We are supposed to find out the radius. So this radius is question mark. And second is find out the volume. So 2 straightforward questions. Firstly, circumference is given. Circumference is 2 pi r, correct? So can I say 132, which is the circumference, is equal to 2 into pi is 22 by 7 into r. R is equal to 132 multiplied by 7 by 22 into 2, correct? So 2 ones are, this becomes 66, 22 ones are, 22 threes are. Therefore can I say the radius is 21. So we got the value of r. The value of r is 21. So r is how much? R is 21 centimeter, correct? Now we are supposed to find out the volume. R is 21 and what is the height? Height is 25 centimeter. How do we find out the volume of cylinder? The volume of cylinder is given by pi r square h. That is pi r square h. So volume will be equal to 22 by 7 into r square. That is 21 into 21 into 25. 7 ones are, 7 threes are, 22 into 3 is 66, then 66 into 21. So 66 into 21 gives me 1386, and then again I need to multiply 1386 with 25. 6 5 is 30, then 8 5 is 40 plus 3 is 43. 5 3 is 15 plus 4 is 19. Carry 1. 5 1 is 5 plus 1 is 6. This is 0. 6 2 is 12. 8 2 is 16 plus 1 is 17. Carry 1. 3 2 is 6 plus 1 is 7. And this is 2. Correct? So this becomes 0. 5. 9 plus 7 is 16. 7 plus 6 is 13 plus 1 is 14. So we get 34650. So that is equal to 34,650 cubic centimeter. So this is the volume of the required cylinder. I hope this question is clear to all of you. Simple, straightforward question. Just make sure that you don't make mistake here in the calculation. Perfect. Let's continue. Okay, so let's have a look at new question now. It says the following figure represents a solid consisting of a right circular cylinder with a hemisphere at one end and a cone at the other. Their common radius is 7 centimeter. The height of the cylinder and cone are each of 4 centimeter. Find the volume of the cylinder. So here we need to find out the volume. Okay, so there are 3 parts. First part, if you see, this is cone, this part is cylinder, and this part is hemisphere. Correct? What is given to us? In the figure, if you see, the height of the cone is given. Height of the cone is 4. Then the radius is given. Common radius is 7. Obviously, if this is 7, this is also 7. Then what else is given? Height of the cylinder is also given. So this height is 4. We are supposed to find out the volume. So if I focus on the cone, so can I say for cone, height and radius is given. So I am taking this as h, that is 4 centimeter. Radius I am taking, that is also given, which is 7 centimeter. That is for cone. For cylinder, you can split it like this. For cylinder. For cylinder. Now see, what they are saying is, the height of cylinder and cone are 4 each. So I am not taking capital H here, I am taking small h only because the height is anyway same, that is 4. I am not taking h1 and h2. We take h1, h2 generally when we have 2 different values, right? So this is 4 centimeter height and radius is again 7. And then for sphere, okay, for hemisphere, not sphere, for hemisphere, what is the radius? Can I say? For hemisphere, the radius is given, which is 7 centimeter. Correct? Cone, cylinder, hemisphere. Perfect. So can I say volume of the figure or whatever the object is equal to volume of cone plus volume of cylinder, isn't it? Plus volume of hemisphere we need to add all the volumes, right? Then only we are going to get the total volume, isn't it? So can I say this is equal to volume of cone, that is 1 by 3 pi r square h. Volume of cylinder is pi r square h. And volume of hemisphere is 2 by 3 pi r cube. Correct? So can I take pi r square common. So if I take pi r square common, say pi and r square I have taken common, I get 1 by 3 h plus h plus 2 by 3 r. Correct? Pi r square is common. So this is 1 by 3 h, this is h, this is 2 by 3 r. So this becomes 22 by 7 into r square is 7 into 7. Inside the bracket, I have 1 by 3 multiplied by h is 4, plus h is again 4 plus 2 by 3 into radius is 7. So this gets cancelled. 22 into 7, that is 154. This becomes 4 by 3 plus this becomes 7 to the 14. 14 by 3 plus this becomes 4. So that is further equal to 154 multiplied by 18 by 3 plus 4, that is equal to 154. 18 by 3 is 6 plus 4, that is 154 multiplied by 10, that is 1540 cubic centimeter. So 1540 cubic centimeter is the volume of this entire solid. Generally what mistake children do is they solve separately. They solve cone separately, cylinder separately, hemisphere separately. See students, you don't have to solve it separately. Always write it down once. See what is taken common, because whatever you take common, you have to then write it down only once, right? And then multiply further. Otherwise you have to do it 3 times. Take the value of pi 3 times in. So there is no point in taking pi 3 times, getting it complicated by taking the fractions, right? Okay. Let's continue further. So here is a new question. Again, let's go slow. Let's try to understand the question first. It says a solid metallic sphere of radius 6 centimeter is melted and made into a solid cylinder. So there is a metallic sphere which is melted and made into a solid cylinder. Correct? Of height 32 centimeter. And this sphere has the radius is given. Radius is 6 centimeter. Okay. So this is 6 centimeter. And the height of the solid cylinder is given. The height of the solid cylinder is 32 centimeter. Find the radius of the cylinder. Correct? Okay. So this sphere is given and this cylinder is given. Correct? We are supposed to find out the height of the cylinder. Radius is already given. So can I say volume of sphere is equal to volume of cylinder? This I already know, but what is the question? What is asked? Okay, we are supposed to find out the radius of the cylinder. Anyways, we are going to get it from this only. Whenever they say melted, basically they are talking about volume. Always remember. Whenever they say melted and recasted, so they are talking about 2 volumes, and the 2 volumes are always equal. R as the radius of this particular cylinder, and capital R over here, capital R as the radius of the solid sphere, which is 6 centimeter. Volume of sphere is given by 4 by 3 pi r cube, that is equal to volume of cylinder, which is pi r square h. So this is r, don't cancel that, correct, because both the r can be different here, but definitely pi can be cancelled. So can I say 4 by 3 r cube? So I get 4 by 3 capital R cube is equal to r square h. Here is r square h. So 4 by 3 into r cube. R cube is 6 into 6 into 6. That is equal to r square h. R square. We'll keep r square as it is. H is how much? H is 32. Correct. Can we solve this further? Yes, we can do that. 3 ones are, 3 twos are. So you have 4 into 2 into 6 into 6 divided by 32 is equal to r square. So 4 ones are, 4 eights are, 2 ones are, 2 fours are, correct? 2 twos are, 2 threes are, 2 ones are, 2 threes are, correct? So r square is equal to 3 into 3. So r square is equal to 3 into 3. So basically r will be equal to 3. So this r is what? This r is radius of cylinder, right? So this is radius of cylinder is 3 centimeter, correct? So we got the radius of cylinder, that is 3 centimeter. Perfect. Then we are supposed to find out the curved surface area of cylinder. So we have got 2 marks. This is for 2 marks. Curved surface area of cylinder. What is the formula? The formula is curved surface area is given by 2 pi RH, right? That is 2 into pi into r. R is 3 into h. H is given. H is given already. Height of the cylinder is 32. So let us take 32. Now that's your choice to take the value of pi. If you want to take 22 by 7, you can take 3.14 also. That's not a problem. The problem with 22 by 7 is you cannot do any cancellations here. But fine. 2 into 22 by 7 into 3 into 32. Correct. So 32 into 3 is how much? 96. 96 into 2 is 192. So 192 into 22. So you get 4224 by 7, right? So that is equal to 7 6 are 42, correct? Then 0. Then you get 2 4 24, 7 3s are 21, then dot 30, then 7 4s are 28, then 20, then 7 2s are 14. So approximately 603.42 centimeter square is the surface area of the cylinder. Perfect. Let's have a look at a new question now. It says a solid spherical ball of radius 6 centimeter is melted and recast. Melted and recast. So whenever this term melted and recast comes into picture, we are talking about volume. So there is a solid spherical ball. So there is a solid spherical ball of radius 6 centimeter. So the radius is given 6 centimeter. This is melted and recasted into 64 identical spherical marbles. 64 spherical marbles. That means they will be small. like this. Like this, there are 64. We're supposed to find out the radius of each marble. So now what we can say is, for this solid spherical ball, for solid spherical ball, can I say radius is 6 centimeter, and for marble I can say let small r be equal to the radius, correct? So what we are saying is, we are considering small r as the radius, and we are considering capital R as the radius of the spherical ball. So now understand, what we can do is, we can say that volume of one big spherical ball, right? One big solid spherical ball is equal to 64 times volume of one marble, correct? So this is pi r cube, right? That is 4 by 3 pi r cube is equal to 64 multiplied by 4 by 3 pi small r cube. I hope this part is clear to all of you, correct? Now the calculation becomes very easy, because 4 by 3 will get cancelled, pi will get cancelled. You get r cube is equal to 64 multiplied by small r cube. But is capital R given? Yes, it is already given 6 centimeter. So can I write this as 6 the whole cube is equal to 64 multiplied by r cube. So can I say r cube is equal to 6 into 6 into 6 divided by 64, correct? Now see, can I write down 64 as 4 into 4 into 4? Yes. So can I say r cube is equal to 6 into 6 into 6 divided by 4 into 4 into 4. So if I take cube root on both the sides, so I can say r is equal to cube root of this part, that is 6 into 6 into 6 divided by 4 into 4 into 4, and we are taking the cube root, right? So only, this is repeating 3 times, so only one part will be remaining. So that gives you 6 by 4. If I divide this by 2, 2 2s are 2 3s are 3 divided by 2 is 1.5. So the spherical small marbles that you have, the radius of each marble, right? What is the radius? The radius is radius of each marble is 1.5 centimeter. I hope this is clear to all of you. Easy? Perfect. So let's have a look at a new question now. It says a model of high-rise building is made to scale 1:50. So obviously, when you make a model on the paper, it looks small, but the actual building is very big, right? So that's what they're saying. A model of a high-rise building is made to scale of 1:50. If the height of the model is 0.8 meter, find the height of the actual building. This is a very simple and a straightforward question. So basically what they're trying to say is, suppose if my model of building looks like this, and the height over here, height of this model is 0.8 meters, then obviously the building is going to look very big, and the scale is given 1:50. So obviously if I want to find out the actual height of the building, all I need to do is scale it 50 times, that is multiply 50 times. So can I say the answer to my part 1 would be like this. The height of the model is given, height of model is 0.8. We can say let the height of building be say h meters, and the scale is given. Scale is 1:50. So can I say 1 by 50 is equal to 0.8 by h. So 1 by 50 is equal to 0.8 by h. So h goes there. So 0.8 into 50. So h will be equal to 40 meters. So 40 meters is the height of the building. Now what they're saying? They're saying if the floor area of the flat building, okay, the floor area of the actual building, the floor area is given, this area of the building is given, is 20 meters square, then find that of the model, then find the area of the floor model. So again the ratios, see, if I take A1 as the area of model, and A2 as the area of floor building, see, when we talk about area, we are talking about two dimensions here. So this scaling is happening for only one dimension, that is length. But now we are going to include length and breadth. So here also 50 times it will be there. So length and breadth both are going to be extended by 50, scaled up by 50. So here I can say 1 by 50 into 50, correct, 2 times, will be equal to, we are supposed to find out the floor area of that model, right? So we'll take it, so I can say area of the floor model, that is A1 by A2. This ratio, what is A1? That is area of the floor model, which we are supposed to find out. Area of the building is given, which is A2, which is 20 meters square, correct? So A1 by 20 meters square will be equal to the ratio of the scaling, correct? So can I say this will be 1 by 50 into 50. We're going to take it 2 times because here we are talking about meter square. So scaling will happen 2 times, that is for length and breadth. So can I say A1 will be equal to 20 divided by 50 into 50. If you solve this further, 0, 0 gets cancelled, and then 2 ones are 2, 25 is a 25 into 5 is 125. So can I say A1 is equal to 1 by 125, correct? So 1 by 125 meter is the answer. If you want to convert this into centimeter, we know that 1 meter is 100 centimeter. So this becomes 100 by 125 centimeter, that is equal to 0.8. So 0.8 centimeter is the final answer, correct? I hope this is clear. Okay, so let's have a look at a new question. It says, from a solid wooden cylinder of height 28 centimeter and diameter 6 centimeter, 2 conical cavities are hollowed out, right? The diameter of the cones are also of 6 centimeter and height 10.5 centimeter. The question says, we are supposed to find out the volume of the remaining solid. We are supposed to find out the volume. Find the volume of remaining solid. Now looking at this, we can easily analyze how do we find out the volume of remaining solid. Firstly, we'll find out volume of cylinder, correct. After finding the volume of cylinder, we will subtract 2 times volume of cone, right? We'll subtract 2 times volume of cone, correct? And that is how you can find out the volume of the remaining solid. So this is the figure. What is given to us? Let's try to understand. The height is 28. Here, the height of the cone is 10.5, and what is the radius given? We need that. So this entire diameter is 6 centimeter. So can I say radius is 3 centimeter? So let's talk about cylinder first. So I can say for cylinder, what is the height? Height is 28 centimeter. What is the radius? Radius is diameter divided by 2. That is 6 divided by 2. That is equal to 3 centimeter. So what will be the volume? So the volume of cylinder will be equal to pi r square h, that is 22 by 7 into r square. R square is 3 into 3 into h. H is 28, correct? You can solve this. 7 ones are, 7 fours are. 22 into 4 is 88. 3 into 3 is 9. 9 eights are 72. 2 carries 7. 9 eights are 72. 72 plus 7 is 79. So 792 cubic centimeter is the volume of the entire cylinder. For cylinder, the height is 28, radius is 3, volume of cylinder is pi r square h, 22 by 7 into 3 into 3 into h. 7 ones are 7 fours are, then directly 22 fours are 88, 3 threes are 9, and then 792. Now we can say for cone, what is the radius? The radius is 3 centimeter. What is the height? The height is 10.5 centimeter. So what will be the volume? Volume will be 1 by 3 into pi r square h, that is equal to 1 by 3 into 22 by 7 into r square, that is 3 into 3 into h. H is 10.5, correct? So can I say this volume is 1 by 3 into 22 by 7 into 3 into 3 into 10.5 can be written as 105 by 10. So let's solve this. 3 gets cancelled, right? Then 7 ones are 7, 3 5, 35, 7 5s are 35, correct? 15 sevens are 105. Then 15 and 10, you can divide by 5. 5 twos are 5 threes are 2 ones are 2 11s are 11 into 3 is 33. 33 into 3 is 99. So volume of one cone, see, understand, volume of one cone is equal to 99 cubic centimeter. So what will be the volume of two cones? Therefore, volume of two cones will be equal to, because two cones are removed of the same radius and height, that is 2 into 99, which will be 198 cubic centimeter. The volume of remaining solid is equal to volume of cylinder minus volume of two cones, correct? That is 732 minus 198. So that is equal to 534 cubic centimeter, correct? So 534 cubic centimeter is the volume of this remaining part. I hope this question is clear to all of you. Very simple and easy question. Let's continue further. So the next question says volume of a cylinder of height 3 centimeter is 48 pi. Then what is the radius of the cylinder? This is an easy question, right? Volume of the cylinder is given. How much is the volume? Volume of the cylinder is given 48 pi. Height is given. Height is 3 centimeter. We are supposed to find out the radius. So radius is question mark. Now, what is the formula? The formula for volume is pi r square h. Correct? So here volume is pi r square h. But volume is already given. How much? 48 pi. So 48 pi is pi into r square into h. H is 3. So pi gets cancelled. So 48 divided by 3 is equal to r square. So r square is equal to 16 because 48 divided by 3 is 16. So r will be square root of 16, that is 4 centimeter, is it? Yes. So the radius of the cylinder is 4 centimeter. This was an easy question, straightforward, just asked for 1 mark. Okay. Now let's have a look at a new question. Let's try to understand the question first. It says a solid in the shape of a hemisphere of radius 7 centimeter surmounted by a cone of height 4 centimeter. So basically you have a cone and below that you have hemisphere. So cone is surmounted by a hemisphere. A solid in the shape of hemisphere of radius 7, radius is 7, radius of the hemisphere is 7 centimeter, and height of the cone, this height of the cone is also given, that is 4 centimeter. The solid is immersed completely in a cylindrical container filled with water to a certain height. So there is a cylindrical container. There is a cylindrical container, correct? And it has some height. It has some height, as in the entire height is some height which we don't know, and it is filled with water up to a certain level. Okay, we are not bothered about that. Now what they are saying is that this solid is immersed in it and the water level rises. But they have given that the radius of the cylinder is 14 centimeter. The radius of the cylinder is given, which is 14 centimeter. And then after this is placed inside this, the water level rises. So basically the water level rises by some value. How much height we don't know. I can take that as x. The question says find the rise in water level. That means we are supposed to find out this particular height. Indirectly we are supposed to find out x. So if I just remove this part, can I say there is a cylinder formed here? Where this part is x. Radius is already given 14 centimeter. Correct? Now can I say the volume of this particular solid and the volume of the water raised will be equal. So you can see that this solid and the rise in the water level, both the volumes are going to be equal. So let's talk about the solid first. You can say for solid we have the hemisphere, so let the radius be r, let radius be r, right? So radius is already given, r is equal to 7, and in this solid for cone radius is 7 and the height is 4 centimeter, right? So can I say volume of the entire solid is equal to volume of hemisphere plus volume of cone, isn't it? What is volume of hemisphere? 2 by 3 pi r cube. What is volume of cone? 1 by 3 pi r square h. So 2 by 3 pi r cube is the volume of hemisphere. 1 by 3 pi r square h is the volume of cone. Can I take 1 by 3 pi r square common? So 1 by 3 pi r square is common. 1 by 3 pi r square is common. So only 2r will be remaining here. So 2r plus, here we will have h. So this becomes 1 by 3 into 22 by 7 r square, 7 into 7 inside the bracket 2r, that is 2 into 7 plus h is 4. So 7 gets cancelled. So this becomes 1 by 3 into 22 into 7. 2 into 7 is 14 plus 4. That gives us 18, right? So this is equal to 1 by 3 into 22 into 7 into 18. So 3 ones are 3 6s are, isn't it? So 22 into 7 into 6. 22 into 6 is 132 and then into 7, correct? You can solve this further, or else if you want to keep it, you can keep it like this, because anyways we are going to solve this further. So 132 into 7 cubic centimeter. This is the volume of the solid, that is 132 into 7 cubic centimeter. Now after this, we don't know the raise in the water level, right? So can I say the rise in water level, Bx, and the radius of the cylinder is 14. Therefore, what will be the volume? Volume of the raised water, which is in the form of cylinder, is pi r square h, that is pi r square h, that is equal to 22 by 7 into r square, that is 14 into 14, and we have considered the height as x. Now can I say the volume of the raised water is same as the volume of solid, correct? So just equate this. Volume of solid is 132 into 7. So here I can write down volume of raised water That itself is the volume of solid. That is 132 into 7. Correct? So solve this now. You get 132 into 7 into 7, 7 goes here, divided by 22 into 14 into 14, and that is equal to x. So 7 ones are, 7 twos are, 7 ones are, 7 twos are. Correct? 2 ones are, 266 are, 2 ones are, 233s are. So x is equal to 33 divided by 22. If I divide this by 11, I get 3 by 2, and 3 divided by 2 is 1.5 centimeter. So 1.5 centimeter is the rise in the water level. The water level rises by 1.5 centimeter, right? So whatever cylinder we had, and this is the water inside it, and the radius is 14, the height here is 1.5 centimeter. I hope this part is clear to all of you. Easy? Okay, let's continue. So let's have a look at one more question. It says a solid metallic cylinder is cut into two identical halves along its height as shown in the diagram. So the diagram is given. The diameter of the cylinder is 7 centimeter. Diameter is 7 centimeter. Diameter of the cylinder is 7 centimeter. And the height is 10 centimeter. So this height is 10 centimeter. And the diameter of the cylinder, this diameter is 7 centimeter. We are supposed to find out the total surface area of both the halves. So total surface area of this and total surface area of this. Correct? It is cut in the middle. Now understand. To find out the total surface area of both of them, if I again combine them together, obviously I need to find out the total surface area of cylinder, because if I combine them, I'll get the cylinder again. So combine it, get the cylinder again, but middle two rectangles are formed. Right? If you see, these two rectangles are formed, and the length of this rectangle is 7 and the width of this rectangle is 10. So can I say the total surface area of both halves will be equal to the total surface area of cylinder, the entire cylinder, plus 2 multiplied by area of rectangle. So this was the hint. Once you get this, you can easily solve this problem. So let's focus on the values now. Again, the height is 10, the diameter is 7. So we can say for cylinder, for the main cylinder I am saying, the radius is diameter divided by 2, that is 7 divided by 2 centimeter, correct? Because the diameter is 7, radius will be 3.5. You can keep it as 7 by 2. And then we are supposed to find out the total surface area, for which we need the height. Height is 10 centimeter. So let's find out the total surface area of cylinder now. So what will be total surface area of cylinder? That will be 2 pi r h plus r, right? That is equal to 2 into 22 by 7 into r. R is 7 by 2 into h plus r, that is 10 plus 7 by 2, correct? That is equal to 7 7 gets cancelled, 2 2 gets cancelled, you get 22 into 10 2s are 20, 20 plus 7 is 27 divided by 2, right? So that gives you 2 ones are, 2 11s are, and that is further equal to 297 centimeter square. So 297 centimeter square is nothing but the total surface area of the cylinder. Now we need to find out the total surface area for these two halves. So can I say for rectangle, the length is equal to diameter. And the breadth is equal to height. These I am talking about the cylinder. So can I say length will be equal to the diameter, which is 7, and breadth will be equal to the height, which is 10. So what will be the area? So can I say the area will be equal to length into breadth, right? That is 7 into 10, that is 70 centimeter square. So now what will be the area of two rectangles? So I can say area of two rectangles will be equal to 70 into 2, that is 140 centimeter square. Now once I get the area of the two rectangles, now I can say that the area, which is the total surface area, I am talking about the surface area of two halves, will be equal to the total surface area of cylinder, that is TSA of cylinder, plus 2 times area of rectangle, that is equal to total surface area of cylinder, which we have already calculated. How much? 297 plus 2 multiplied by area of rectangle. How much is area of rectangle? It's already 70, that is 2 into 70, 140. So 297 plus 140 is equal to 437. This is centimeter square. So once we get the total surface area of these two halves, now can we find out the total cost of painting? So we can say that the total cost, okay, let's do it here. So what is the cost given? The cost is given cost of painting per meter square is given, right? How much is that? 30 rupees. Therefore, cost of painting 437 meters square is 437 multiplied by 30, right? So 13110 rupees is the cost, right, of painting these two areas together. I hope this question is clear to all of you. Okay, let's continue with one more question. So the question says, oil is stored in a spherical vessel occupying 3/4 of its full capacity. So there is a spherical vessel like this. So there is oil stored, but not entire sphere is filled. It is 3/4 of the total capacity. Radius of the sphere is 28. So radius of the spherical vessel, this radius is 28 centimeter. This oil is then poured into a cylindrical vessel. This is poured into a cylinder. With radius 21. Find the height of the oil in the cylindrical vessel, correct up to nearest centimeter. So we are supposed to find out the height of the oil in the cylindrical vessel. So this height. Firstly, what is given? It is given that oil is stored in spherical vessel. So here we have 28, which is already given, but oil is not completely filled here. It's filled up to 3/4, right? So firstly, can I say for sphere, what is the radius? Radius is 28 centimeter. What will be volume? Volume of sphere is 4/3 pi r cube, but it is filled up to 3/4, right? 3/4 of the total capacity. Correct. So can I say the volume of oil is equal to 3/4 into volume of sphere? Correct. So now can I say volume of oil is equal to 3/4 into volume of sphere, which is 4/3 pi r cube. 4 gets cancelled, 3 gets cancelled. So volume of oil is equal to pi r cube. Now oil is poured into cylinder. Now this oil is poured into cylinder. So can I say for cylinder, what is the radius? The radius is 21 centimeter. Height we don't know. So height is question mark here. This is volume of oil in cylinder will be equal to pi r square h, where h is not the entire height, h is the height up to which it is filled. So volume of height oil in cylinder and the volume of oil in sphere will be equal. So here can I say volume of oil in sphere is equal to volume of oil in cylinder. So what is the volume of oil in sphere? It is pi r cube. What is the volume of oil in cylinder? It is pi r square h. Let us do one thing to differentiate r. Let me take this as capital R. Correct. So this gets cancelled. So can I say r cube, small r cube is equal to r square into h, but what is r, small r? That is this, 28. So can I say 28 cube is equal to r square? R square means that r, the other r. 21 square into h. So this becomes 28 into 28 into 28 by 21 into 21, that is equal to h. So 7 3s are 7 4s are 7 3s are 7 4s are. So 4 4s are 16 and 16 into 28. 4 4s are 16 and then 28 into 16, right? So 8 6 are 48, carry 4. 6 to the 12, 12 plus 4 is 16, this is 0, this is 28, this is 8, 8 plus 6 is 14, 448. So this becomes h is equal to 448 divided by 9. Now divide this, 448 divided by 9, right? 9 4 is 36. This is 8, 8, 9 9s are 81, 7 dot 0, 9 7s are 63, then again 7 0, then this is going to repeat, that is 49.77, correct? 49.77 approximately. If you round it off to the nearest place, that is 50. So the height of this is 50 centimeter. And that's it. So I hope you have enjoyed this session alongside me. See you again in the next class. Thank you so much. Until then, keep learning with top scholars.